Science is the constant exploration of how and why natural phenomena occur in our natural world. Science helps us understand the behavior of the matter around us, helps us make sense of things. It helps explain things such as why a piece of wood is able to float on top of water and why a rock will sink to the bottom of the lake. Science is the key to opening up our understanding of the world as we experience it. In the scope of our lab course, we strive to provide a tangible experience or a tangible exploration of the scientific principles that help make sense of the natural phenomena that we encounter in our natural world. These scientific principles are important because they explain how we experience the natural world around us. So we have natural phenomena that occur and that we observe. Then we have scientific principles that help explain why and how these natural phenomena occur. And for our labs, our lab experiments provide that tangible experience of these guiding scientific principles. And ultimately, we want to explain these concepts and tie them to natural phenomena so that we enable your ability to help harness the world around us as future scientists and engineers. One of the key scientific principles is density. Density is defined as mass per volume. It's essentially the amount of stuff that is in a given space. Density is a key concept in explaining the behavior of matter around us. It explains why a piece of wood floats and a rock will sink in water, right? And this is because the piece of wood is less dense than the water, enabling it to float on top. The rock, being more dense, will sink to the bottom of the water. And this is essentially because the rock has more stuff than the water and more stuff than the wood in the same amount of space or volume. Now, the discovery of density is attributed to Archimedes. Archimedes was a Greek mathematician who in 250 BC was commissioned by the king of Syracuse, Syracuse being in Sicily, Italy, to determine if a goldsmith who had made his crown had in fact skimmed some of that gold for himself or not. So Archimedes had a breakthrough moment in solving this case when he submerged himself in a bathtub. Now the breakthrough was that the volume of water that he displaced in his bathtub was equal in volume to him. And that is what is depicted in the image to the left. This is in fact a statue that's on display in a museum in Israel. It commemorates Archimedes' discovery of the volume displacement method. So this discovery enabled Archimedes to determine the volume of the crown, depicted in the animation here. So once he figured out the volume of the crown, he was then able to weigh the crown. And once he has the mass and the volume, he can then calculate the density. Now this density of the crown can be compared to an equal amount of gold in terms of mass, and then measure the volume using the same volume displacement method, and calculate the density of that known pure gold. This, in fact, enabled Archimedes to discover that, yes, the Goldsmith did, in fact, take some of that gold for himself. It is also rumored that upon having made this breakthrough or this discovery, Archimedes ran through the streets of Sicily yelling out, Eureka, which in Greek means I have found it. Now, Archimedes went on to make more discoveries. It's not known what happened to the goldsmith, but chances are his ending was not happy. So for our lab, we're going to use this same volume displacement method that Archimedes implemented. What we will do is we will weigh out your unknown. We will then use the volume displacement method to submerge it in water, and you will be able to measure the volume displaced by your unknown. Now you will have the mass, you will have the volume. From that, you can calculate the density, and then you will compare that value to the list of possible unknowns and their respective densities. And from this, you will be able to help identify the unknown that was assigned to you.